Okay, this is a good question. Minimum of x and x square. The function is defined in this fashion: x minimum of x and x square. So what you need to do is draw a curve of x, fx equal to x, draw a curve of fx equal to x square, and then whichever part is lower, that is your function. Whichever curve is lower for a given value of x, that is your function. And then you can see whether it is continuous from the graph. You will be able to see whether it is continuous, whether it is differentiable, what happens at what point. If you draw the curve of fx equal to x, you know it's a straight line, right? Fx equal y equal to x. The curve of fx equal to x square is a parabola, y equal to x square, right? And it could be something like this, correct? This would be the origin, because both will pass through origin, and this would be 1, because at x equal to 1, y will be 1 for this curve, y will be 1 for the other curve. So this is, so your graph is the lower part of this. So that means your graph is this. I'll draw it here again. Your graph, this is your graph. So your graph looks something like this. This point is 0, this point is 1. And you can see very clearly the graph is continuous. There is no break. So so it is continuous for all x. It is not differentiable at two values of x, which is very clearly x equal to 0, there is a sharp point, sudden change in the slope. At x equal to 1, there is a sharp point, again sudden change in the slope, and therefore it is not differentiable at two values of x. And h dash x is equal to 1 for all x greater than 1. You can see for x greater than 1, my curve is like this, and that slope of that curve is 1. So for all values of x greater than 1, the derivative of the function is 1. So all these three are correct. They have shown you all these guys, how to calculate. They have shown you all those guys. How less than 0 it is x, between 0 to 1 it is x square, x greater than 1 it is x, and then you take the derivative, etc. Okay. But graphically it becomes very easy.